Welcome everyone, and thank you for joining us today on this panel discussion looking at the economic implications of well-to-wake life cycle assessments. I'm Joost Wetterings from Liquid Wind, the Commercial Director. I'm joined by Eberhard Wusterhaus-Gomez from Carbon Clean and Felix Jung, Sustainability Manager. So maybe I can ask you to introduce yourselves, please, and explain a little bit of what you're doing.
Sure. My name, as you said, is Eberhard Wusterhaus-Gomez. I'm the commercial director for Carbon Clean, working with the company since the early beginnings, 7 years back, and with more than 15 years of experience as a technology provider in the areas of chemical absorption with amines, pressure swing adsorption, membranes, and cryogenic.
Yeah, my name is Felix Jung, as you said, Sustainability Manager. So I'm really covering all the sustainability topics at Liquid Wind, corporate and project-wise, but then also looking a lot into regulation, upstream, what is needed to be compliant, producing compliant e-methanol, and then downstream, where can customers, for example, the shipping customers, use our fuel to then leverage it to stay compliant or reach their own decarbonisation targets.
Interesting. And before we go into too much detail, because there's so much here to discuss, I think it's probably nice as well for all of our viewers to be given some insight in exactly what we're doing and what's actually going to be built quite soon. Eberhard, perhaps you can quickly explain what Carbon Clean is doing and where this is all factors in before we go into the detail on the well-to-wake.
Sure. Carbon Clean specializes in the development and technology provider of the carbon capture technologies. In this case, with the chemical absorption with amines. We've been working with this technology since 2012, and we joined the vision together with Liquid Wind in 2016, working for the concept to be realized for the production of e-methanol coming from the recovery of CO2 from flue gases.
Fantastic. And I mean, there's so many different solutions which are now being put on the table. The scale of the problem that we all see is absolutely vast. And as many people know, shipping is one major emitter. And so there's a big problem here. There's lots of other areas as well which need to be tackled. We are now going to be specifically talking about e-methanol. This is where Liquid Wind's basically bringing a lot of different technological players together to produce something called e-methanol, which has lots of different properties, which I think are best really understood when you look at everything on a well-to-wake basis. And to give some kind of scope as to sort of just how much this demand is driving up in our sector, just in e-methanol, or rather green methanol itself, when we looked at the market in shipping last year, the expectations were that by 2030, the demand was going to be hitting around 7 million tons. And now if we look today, we have an extraordinary figure of 39.5 million tons. I mean, it's massive. Why is suddenly a massive sector of the shipping building ships, ordering retrofitted engines and investing so heavily in the sector, Felix?
Yeah, as you mentioned, right, there's a huge push towards decarbonisation in shipping. I basically see three main drivers. They're also interlinked. First, it would be the voluntary sector, companies, shipping companies, setting decarbonisation targets because they want to contribute towards this net zero ambition, fighting climate change. So there's also pressure from all kinds of stakeholders that they have targets for decarbonisation. Therefore, they looking at options to reduce their emissions on a company level. The second one is economic driver. We see an uprise in green shipping services, so based on alternative fuels, and this is driven by the demand side from shipping companies. So these are their customers. Cargo owners, for example, are interested in looking at green shipping because these companies also want to reduce their corporate emissions, and transport is part of their Scope 3, so-called Scope 3 emissions in the Greenhouse Gas Protocol, and that's the shipping of goods, so their own products, and that directly impacts the carbon footprint of their products. And then lastly, we have the regulatory driver. Here we see that decarbonisation is more and more the heart of new regulation. For example, we have Fuel EU Maritime, which targets to be a tool for the uptake of alternative fuels. We have EU ETS that puts a price on CO2 emissions, kind of penalizing every CO2 that you put into the atmosphere, and thereby kind of closing the gap between fossil fuels and alternatives, because it drives up the price of this fossil fuel.
Interesting. And so, I mean, just to take one step back, if you're a shipping company, there's lots of different options on the table now to help tackle your emissions. I mean, there's nascent battery technology, there's other types of fuel, and of course then there's the most basic things with basically reducing your speed and other aspects like that. So, but with Liquid Wind working with Carbon Clean, and the first of the facilities that we've got across the line, which will start being constructed in 2023 to start producing in 2024. What is it about this production process and its well-to-wake analysis which makes it so well suited for the shipping sector?
So first of all, they will start producing in 2025, just a small correction. But we're looking at the well-to-wake term. That's a very established now in shipping. That means we're not only looking at combustion emissions, like it's being done in shipping so far. With the uptake of alternative fuels, we're looking also what's happening upstream. So what are the emissions associated with producing that fuel? And then we get into the whole supply chain and looking at the practices. So for example, for e-methanol, as you mentioned, we start with carbon capturing because we want to reduce the CO2. We're getting kind of a negative CO2 footprint until it's combusted. So then we have kind of a balance and have a net zero fuel because everything that's emitted on board during combustion has been captured before and put into the fuel.
This is a fundamentally defining point here, and this is only capable because of what Carbon Clean's doing. There's some people like to talk about direct air capture, which of course is a nice idea because then it's tackling the net balance of CO2. But Carbon Clean's technology, maybe Eberhard, you can explain a little bit more what it does specifically, which allows a cost-competitive solution for non-abatable CO2s.
Correct. So we base our technology in the point source emission of capturing CO2. That means the post-combustion processes like biomass CHPs, cement kilns, blast furnace, gas turbines, everything that has, in essence, a flue gas with a CO2 concentration. That is where we see the ability of the technology to be much more feasible for the economies of circularity and CCS.
Fascinating. I mean, and then once you extrapolate that further within the production process, so it's hugely energy intensive, but if you can essentially derive all that energy from renewable electricity, CO2 is essentially renewable electricity as part of the circularity, you can able to capture it. All of these aspects, when you come down to looking at a life cycle assessment, means that your actual CO2 footprint, as it were, the fuel, goes lower and lower when you compare it to other fuels as well. Felix, maybe you can elaborate a little bit on some of those points and how we can put that into something which is actually sellable and actually can be defined in a legal contract.
Yeah, exactly. So with the introduction of alternative fuels, we get a whole range of different fuels coming into the market. We have biofuels, we have electrofuels. Biofuels can be very different depending on feedstocks, transport ways of the biomass, the raw biomass. We have sometimes indirect land use change, which is also a big impact factor. So there's a big range of fuels, and they will all come with their own greenhouse gas intensity per megajoule. And kind of like a bit the beauty of e-fuel is that it's such a simple process. From the outside, at least on a high level, we are it's a chemical site. You have renewable electricity, you have carbon capturing on site from for example, biomass CHP, and then you refine this into methanol and are able to then ship that methanol to the customers, and that's the final product. So you have much higher energy density, and therefore you can have a very transparent and low carbon fuel.
So this is interesting. Then take a step back. So Eberhard mentioned taking CO2 from different types of industry and then repackaging and repurposing it. And then Felix, you talked as well about a lot of that biogenic, which I take as really, really green. So like there's different corresponding CO2 intensity. I mean,
so at Liquid Wind we're focusing on biogenic CO2 because we really like that circularity thinking. For example, Flagship 1 is using biomass CHP. There we have forest residues. So all the CO2 that we put into our methanol has been part of the atmosphere before. So that's really what we like and for carbon capture and utilization. And when you look at this well-to-wake approach, that also becomes visible because we have a transparent process.
I mean, I would be right to say that then when we're looking at all these alternative fuels, there's a different CO2 footprint that corresponds to it. Technically then, because for anyone who's looking in the shipping sector, there's a price point which then corresponds to that. Perhaps you can elaborate then on a like-for-like basis. If you look at each different type of fuel, each one has a different well-to-wake analysis. What would be the impact there?
Yeah, exactly. So there are some good published reports. Methanol Institute did something with Studio Gear Up, where they looked at different pathways for methanol production, but then also the Joint Research Center for the European Commission published different values for all kinds of alternative fuels. And here we can really see that e-methanol has about a carbon footprint of 1.7 grams CO2 equivalent per megajoule, and biofuels are more in the range of 10 to 25 grams CO2 equivalent per megajoule. And that kind of corresponds to the amount of fuel that you need to reach your decarbonisation targets, or to be compliant under different regulation. And that's so if we have a fuel with a lower carbon footprint like e-methanol, you're likely to need less alternative fuel to stay compliant, and that can definitely save some money in that sense because you require less of that alternative fuel.
So that's fascinating. So there's multiple different points here which have to be taken into account depending on what type of fuel you are. But that still opens the case there for shipping and how the scale of its emissions. With carbon capture, then possibly there's all sorts of opportunities there as well. Maybe, Eberhard, you'd like to elaborate a little bit on some of the strategies and some of the sort of global outreach that Carbon Clean looks to essentially be rolling out to help tackle this.
Absolutely. The necessity, and we've seen that already, that from what we've seen before and now, there's an exponential improvement in the necessity of this type of low carbon fuels or e-fuels. With this in mind, we're talking about the 40 million tons of methanol required by 2030. In this case, that means for us as a carbon capture technology that we will be required to supply about 55 million tons of CO2 for that to be complied. With this in mind, for us, the biggest strategy is how can we exponentially increase our fabrication, but also improve the fabrication methods. And that means that intensifying the technology is one of the biggest steps of Carbon Clean to provide this innovation in this world of carbon capture technologies, and at the same time improve the economies that are required so that there is a momentum on the demand of these type of fuels.
Absolutely. I mean, it's fascinating. I mean, we just talk about the methanol sector, and as you mentioned as well, that 40 million tons. I mean, the general scope of the emissions is so vast. Both Liquid Wind and Carbon Clean have got huge global ambitions. I mentioned earlier, 50 million tons by 2050. Part of that, though, is also being able to help companies achieve their targets, but do it in a way which is cost effective. I think we talked briefly, and I think that's what you were trying to say there as well, about it was basically the idea is trying to find processes within the industrial process to help bring the cost down. I know Liquid Wind is now very much focusing on a modular concept which allows technological partners like Carbon Clean to essentially improve the process so that every single time ideally it gets cheaper and cheaper for the production process to come down, and that will then translate itself into the price of fuel. But that also makes it very interesting. We talk about some of the legislation with the EU. There's also other global legislation which is out there. There's a possibility essentially to start producing facilities in your own backyard. I don't know if would you like to talk about some of the future projects that Carbon Clean is looking at?
Yes, correct. I think that for us is the opportunity to decarbonize the industrial sectors that are hard to abate. So we're talking about the cement industry, the oil and gas, the steel, and the waste to energy, and where we do see the potential of Carbon Clean providing an impact. With this in mind, our portfolio goes from gas turbines to be decarbonized, which is a very interesting opportunity, which even in a modular sense will provide a bigger impact. When we talk about that, owners in the energy world have 200, 300 assets of small gas turbines that produce probably around 30,000 tons per year of CO2. But when you are able to start replicating this technology over and over again on the same type of assets, then you are actually achieving a decarbonization of 6 to 7 million tons of CO2 every year. And with this envision, we also saw that liquid wind has the same concept. And this is what really brought us together, that pioneer vision of making it a digital twin concept that can be replicated over and over again so that we can actually provide an impact with the production of e-methanol.
And also saying is doing, but I mean, Carbon Clean's footprint already now is fantastic. I think it's 50 projects?
Yes, correct.
Exactly.
We are celebrating our 50th reference together with Liquid Wind, our flagship one. It was very hard work, definitely. There was a lot to discuss, not only inside the companies, the OEMs, but also to bring that confidence to the industry that we have a concept that can be used as a reference and as one of the largest references in Europe in terms of e-methanol, really is a flagship, not only for Liquid Wind or Carbon Clean, but for the whole maritime industry as well.
No, fantastic. And is a proof of concept is no better reinforced than by players like Ørsted, who then have now bought it and will be the ones owning and operating it. Going forward as well, the capability to scale it out is also there. I mean, I think future flagships talked about being around 100,000 ton production. But there's a point here which is very interesting. I think geopolitically, we see the world is constantly struggling with a very complicated supply chain, and of course geopolitics now more than ever has caused lots of complications, to say the least. That has a volatility price impact. The possibility now, if I'm right in understanding, is that anyone could essentially, if you had the right location, you could build one of these facilities, and then that means that there has all sorts of upsides. Now onto the subject of ESG. This is something which is not really ever tackled. Fuel is inherently dirty, but with e-fuels and the facility and how they're produced, this is now an opportunity, isn't it?
Yeah, exactly. So for me, always is when you switch to sourcing alternative fuels, you're going away from just an energy carrier to actually a sustainability and compliance product. And that's why also the value of the fuel is changing. It's not just kind of offering a transport service for the cheapest possible, but also offering the decarbonization. But then when you report on sustainability, you're also including these ESG criteria, as you mentioned, so environmental. That can also include biodiversity, material resources, or indirect land use change, for example. And then we also have the social impacts like human rights, labor rights. So these are all things that need to be considered when you look at sourcing alternative fuels, because with that well-to-wake approach, where you get visibility and transparency into the upstream production, there can also come some responsibility, right? And then when you report the ESG on ESG, sourcing a very transparent process and produced in a very ethical way, becomes actually an ESG opportunity for the shipping company.
Which hopefully will then translate itself into all sorts of voluntary aspects. And of course, for us, we'd always hope that has a price translation, but for the rest of the world, of course, it just helps clean up the act in more ways than one. We're looking at the first facilities which are located in Sweden, the reasons for being the biogenic CO2, and quite a few of the other sort of future facilities are basically planned to be in locations where Liquid Wind can find the sort of very green credentials, so green electricity and the biogenic CO2 sources. We haven't actually talked about different types of biogenic CO2, which is something which I think is important to take into consideration for well-to-wake.
I mean, we have different options. So we're working on biomass CHP. That's kind of right now it's our first project where there is forest waste residues combusted for electricity and heat. But we can also look at waste-to-energy plants. There usually is quite a high biogenic fraction of that we can use. So the pulp and paper industries also as a CO2 source is a good opportunity. What we're looking at.
Fantastic. I mean, there's so many different points that we can go into so much more detail about. But I mean, I think the fundamental message that we're keen to point out is that well-to-wake is the new process to which everyone should take into account what the overall CO2 footprint is of the fuel they buy. It has all sorts of impacts that can be used in many different ways, not just on the emission factor, but also on the voluntary reporting and on your wider ESG. But it's interesting, isn't it, when we talk about all these different solutions that are out there, there's so many different choices to make. But right now, today, if you were to use one of our fuels using the technology from Carbon Clean, doing all the recycle process that we talk about, there's a capability to essentially have a fuel which is then nearly zero emitting. And so this is a game changer, and so it really allows many different shipping companies to meaningfully make progress towards their decarbonisation targets. I would invite anyone who wants to go into a bit more detail about some of the points that we talked about to go online, because we have a link available for Felix's white paper. And then in that, he goes through to much more detail, and specifically on some of the EU legislation, which is probably the most relevant at the moment. So, and otherwise, I think if I can thank you both very much for your time. I don't know if there's any other points that you'd like to highlight.
From our side, Carbon Clean is committed for the decarbonisation of the heavy industry. And this is a real proof, working with Liquid Wind, that this is possible. Coming from a background of a startup and scaling up and proving that the technologies that we supply are aligned with the necessities of the industry that are hard to abate, to adopt this type of technologies, really makes us really proud. And for us, the next step is going to be the intensification, which is the Cyclone CC technology. And this is where we do see the potential of creating a bigger impact in this industrial world. For us, the philosophy is, how can we make this world a better place, not only for us, but for future generations. And we're committed to bring this to that point where we can see that Carbon Clean become one of the biggest suppliers in the technology of carbon capture.
That's a very bright, exciting future for all of us. Super. Well, thank you very much. Hope you enjoyed the talk.